Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today's problem is on matrix. We have to figure out the closest distance of 1 from 0. So let's jump into the problem statement, understand it and start solving. We are going to solve it in time complexity of O of m cross n. Last time we have resolved insert interval. You can find it in the list. Let's go with 0, 1 matrix. So 0, 1 matrix is 0, 1 is binary, so it's binary matrix. Given an m cross n binary matrix, return the distance of nearest 0 for each cell. The distance between two adjacent cells is 1. Okay, so problem statement is very clear. We'll understand it from this example. 0, 0, 0, 0, 1, 0, 0, 0, 0. We have to return the closest distance to a nearest 0. So for this is already 0. The closest distance is 0 as well. So in the answer 0. Then 0, 0, 0. So again 0, 0, 0. Now this 1. The closest 0 from this cell is this cell, this cell, this cell or this cell. And adjacent cell distance is 1 as they have mentioned here. So answer for this one would be 1. Then 0, 0, 0, 0. Let's understand from this example. For 0, answer would be 0. For next 0, again 0. For 0, 0. For 0, 0. So for zeros, the answer would be 0 only because they are the closest to themselves. And when we get any other number, so in this case 0, 1 will be getting 1 only. So we get 1 here. The closest 0 is 1 element away, 1 cell away, so 1. Then 0. Then 1, we have 1, 0 right above it. So 1. Now for this middle one, there is no one on the left, on the right, on the bottom or on at the top. It's not directly attached to any 0. So the closest path it can take is either go right up or up right, up left or left up. So the closest 0 is 2 cells away from this one. So the answer for this one would be 2. And then for the last one, 1 again. Okay. Now, with this understanding in mind, we are clear with few things. One is, whenever the element is already 0, then this answer is also going to be 0. Whenever it is 1, we have to figure out the smallest number closest on the top side, left side, right side and at the bottom side and add 1 to it, right? Now, when we are coming from the top approach, we will come from the top down approach and will optimize all the possible solutions in all the directions. We'll update the top, we'll update the left, but we cannot update the right and bottom because we do not know whether they are updated or not, right? So that's why we'll need to go through this problem twice. First we have to go from top left to right bottom and then from right bottom to top left. Okay, so let's understand this. Okay, I'll make you understand from another code example as well. Let's start solving and then let's check. Okay, so we need few variables to understand and solve this problem. We'll keep maximum length. So maximum length could be 1 0 is here and 1 1 is here, 1 1 1 1 1 1 1 1 1 and a 0 in the end. Maximum length could be this length plus this length, right? So we'll say int max length is equal to matrix dot length plus matrix column dot length. Okay, now for the top down we'll have two variables. So we'll say int top is equal to 0, int left is equal to 0, int right is equal to 0 and int bottom is equal to 0. Okay, because for each element we need to find what is the lowest in the top, left, right and bottom and add 1 to it, right? That will be the closest path. So we have initialized all of them as by 0 as of now. Now we'll iterate from top left to bottom right. Okay, I'll say for int I is equal to 0, I is less than mat dot length I plus plus. Simple. Simply we'll start the j loop. Int j is equal to 0, j is less than mat of 0, that is column dot length j plus plus. Now first the base thing, if matrix of ij is equal to 0, that means we don't have to change anything, right? So we can simply say continue. Else, so if it is 0, the solution is going to be 0 only, so we'll not change anything with the matrix, because in the end we'll be writing simply as return matrix, right? So if 0, we don't make any change. Else, so when it is 1, now we need to find out what is the minimum value in the top, left, right and bottom. But since we are coming from this direction, we can only be sure of top and the left values. The right and bottom values we can take, but we are not sure of them. So why take them right now? Okay. So we'll say left is equal to max length. For now, first we'll initialize it with the maximum length, max length, and we'll say left is done, top is equal to max length. Okay. Now update the left distance if possible, right? Because when we are at the leftmost column, we cannot update the left, there is no left, right? So we have to check if I is greater than 0, left is equal to matrix I minus 1 j. We'll get the value of left by I minus 1. If we are at this position, this is our left, right? Similarly, update top distance if possible. What's the condition for that? If j is greater than 0, so we can say top is equal to mat I j minus 1. Now we can say matrix I j is equal to math dot min, so minimum of the two, left and top, and then we add 1 to it, right? Like in this case, for minimum of 2, 0 or 0 is 0 plus 1 for this cell. That will be the answer. Okay, let me just write a comment for this. Okay, set the current cell distance to the minimum of left and top distances plus 1, right? Now as of now we have only done from top left to bottom right approach. Let's see what happens if I try to run it now and submit it. Okay, you can see it's passing all these example test cases. That's why it's difficult to understand why do we need to perform the bottom up approach as well. Okay, but let's see if I go for submission and it takes my approach or not. Wrong answer, right? Let's understand this wrong answer. Let's copy it, because it's important to understand why we need a bottom up approach as well in this case. Okay, means one extra loop for bottom up. So let's understand this code example. This is the input array. Okay, now we'll create the output from this. As of now, what's happening is, for this array our output is coming 0 1 0 1 2, 0 1 0 2 1 2 was expected, this is correct. This is coming wrong and this was expected. This is same, this is coming wrong and this is coming wrong. Okay, let's see. Now if we follow our approach, for 0 we should get the solution 0, for 1 Now we have 0 behind us, so we can take 1. Now one more thing is, some of you might say that why not, when we are traversing from top left to bottom right, why not check for the left, top, right and bottom as well? So as in this case we are only checking for the left and top, why not check for the right and the bottom also? We can do that, but we are not sure that they are updated values or not. So let's understand it in this example only. Okay, here we'll consider the left, top, right and bottom. So for this one, solution would be 1. For 0, of course 0. For 1, it will be 1 because we have a closest to this. For this one, you can see I can go left, I see 1. Top, nothing is there. Right, nothing is there. Bottom is 1. So the answer we are going to write should be 2. Correct? 1 plus 1, 2. Now in the next one, we'll see 1. So we know 0 is above. So 1 is the answer. We see 1. From here we get 1. From here we get 1. From here we get 0. So 0 plus 1, 1. We can write 1 as the closest. Then for the 0, 0. And for this one, we have a 0 behind it. So we can say 1. Okay. Let's see where we are right now. We were putting 2 here, but we should get 1. Okay. But this is because in our current solution we are going only top and left, but for this approach I am discussing top, left, right, bottom, all. Okay. Now next time I reach this 0, 0, 0, 0, 1, 0, and I see we can update it as 0, 0, 0, 1, 0. Next would be 1, 0, 1, 1, 1, and in the end 1, 0, 0, 0, 1. Now let's see, is this the expected output? 0, 1, 2, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, and 1, 0, 0, 0, 1. That is correct, right? So why not use this approach? We can do that, but it is going to fail again. Why? When will it fail? Let's create the example where it can fail is, let's make this one 1, let's make this as 1, and let's make this as 1. Okay. Now in the output section, we'll start from this row, third one. We see 1 on, so we can update it as 1 here. We see a 0, 0 will remain 0, 0, 1, 0, 0. Then we see a 1. On left side there is 1, at the bottom there is 1, and at the right there is 1. Let's make this one also 1, okay, for the change. So this would have been 1 as well. Now pay close attention to this row. The first one is 1. If we consider top, bottom, right, left, we see 1, 1, 1. The minimum of all three would be 1, and the solution will become 2 here, right? But is 2 the correct answer? No, right? Because if we go in top direction 1, 2, 3, it takes 3 steps to reach the 0. 1, 2, 3, 4, we cannot reach any 0. We can go 1, 2, 3 steps to reach this 0. 1, 2, 3, anywhere. So the answer should have been 3. But we are getting 2 here. We are checking the top, right, the bottom, left does not exist. Right? And let's keep updating it, okay? So we checked in all the direction, we updated 2. Now for this one we checked 1, 1, 1, and we update it as 2. The next one would be, there is 1 right above it, so it will remain 1. For this one there is 1 below, so it will remain 1. For this one there is 1 above, it will remain 1. For this one we have 2 and we have 1 on this right, so 1 plus 1, 2. This will be 2. Now this, we have 1, 1, 0, 0 plus 1, 1. So it will be 1 here. Now it will be 0, will remain 0, 1, will remain 1. Okay. Now we are 2, 2, 1, 1, 1, 2, 1, 0, 0, 1. Now This is still not the correct answer, right? Because this one is 3 steps away from 0. So first we followed the approach of top left to right bottom. Now we'll start from the right bottom to top left again. This array will now become our input and we'll start traversing again. So this one is closest, we have a 0 here, okay, so it will remain 1. This 0 will remain 0, 0 will remain 0, 1 will remain. So 1 will check 0 on the back, so 1 will remain 1. Then we come to 2, 2 we check on the back, and 2 will remain 2. Now 1 we check bottom and right, we check bottom, which is 1, and but we have already covered the upper side, right? Or we have already covered the minimum, so we take that and we keep it as 1. For the next one, similarly for the next one, we see 1 1 1. For this one, now we have a 2 here, because 1 2 we can reach in 2 steps. For this one, we'll see the bottom and the right, both of them are 2, so this one should be updated to 3, right? So this is why it is important that first we follow the top to right approach, correct all the array elements, then we go from the bottom to the top and correct all the elements again, because when we are coming from the top left to the bottom right, we are not aware of the optimized solution for the right and the bottom side. Similarly, when we are coming from the bottom to the top, we are not aware of the optimized solution for the top and left. But once we have already solved the top left, in next iteration we'll be aware of them. Okay, let's simply understand it here. Okay, so we solved the iteration of top left to bottom right? Now let's do this iteration again, but from the bottom right corner. Okay, so we'll say iterate from bottom right to top left for int I is equal to, so it's bottom right, mat dot length minus 1, I is greater than equal to 0 0, I minus minus. Okay, similarly for int j is equal to 0, sorry, mat 0 is mat 0 dot length minus 1, j is greater than equal to 0, j minus minus. We'll check the same if matrix of I j is equal to 0, we don't need to touch it, so continue. Else, now we'll check and update bottom and left side, right? Now we are coming from the bottom right corner, so we'll say else left is equal to, first we'll initialize it with the not left, we'll call it the right is equal to max length. First we'll initialize them with the max length. So as in this case we had initialized top and left, now we'll initialize right and bottom. Okay, we have initialized the right, we'll initialize the bottom is equal to max length. Okay, now we'll update them based on the conditions if it is possible. So update bottom bottom distance if possible, so we'll say bottom, no, we have to do a check if I is less than mat dot length minus 1, bottom is equal to matrix I plus 1 j, right? Similarly, update right distance if possible. What's the condition? We should have a row, we should have a column on the right side available. So j is less than mat of 0 dot length minus 1. So we have one extra column on the right side, so we can say right is equal to mat I j plus 1. Okay, Similarly, now we'll update it, but we'll now check it with the original value as well. So we'll say set the current cell distance to the minimum of bottom and right plus 1. So we'll say mat I j is equal to math.min. Again one more math.min. First we'll check for the right and bottom, and we'll add 1 to it, and then we check it for the original value which was set in a last iteration ij. Okay, now let's try to run it and see what happens. Okay, I understand the code could have been little confusing, but don't worry, once you go through the video again, go little slow, you'll understand it. Okay, yeah, so now we can see it beats 99.3% of the answers. Last time we were getting wrong answers, this time all are right. So what we are doing is, first we are going from the top left to the bottom right, then we are going from the bottom right to the top left, and we are following the same approach. If the element is already 0, keep it 0. Otherwise, check the value for the minimum of the left, the right, the top, the bottom, and add 1 to it. Okay, and the overall time complexity of the solution is O of m cross n. That is all from today's video, everyone. If you have any comments, please let me know in the comment section. So please like, share and subscribe. Thank you.